that dy dx should be negative sine x from our exploration. And so we'll go ahead and do an example. Oh no, I'm very sorry. Okay, so my example is going to be y equals 5 cosine of x squared. Okay, so now I am going to take my derivative. I need to take the derivative of my inside, which is 2x, and put it out front. So I already had a 5. I need to multiply by 2x. And then the derivative of cosine is negative sine. So I'm going to have times negative sine, keep the inside the same, x squared. Okay, so when I rewrite this, I should have negative 10x sine of x squared. Okay. And let's do integration. So we know that the integral of cosine of x with respect to x should be sine x plus c. And then we'll do an example. Let's do the integral of 8x cosine of x squared dx. We need to do some u substitution. My u is x squared. My du is 2x dx. Okay. Now notice I have 8x dx right here, but I have 2x dx right here. I need an extra factor of 4 in there. So I'm going to multiply this whole thing by 4. So then I get 4 du equals 8x dx. And notice that I've made this look exactly like what was in my integral already. Thus, I can replace it with 4 du. So I'm going to have 4 cosine of u du. Now I can actually integrate because I don't have all the complicated stuff in there. And the integral of cosine is sine. So I'm going to have 4 sine of u plus c. When I replace my u with what I had, I should get 4 sine of x squared plus c. Not there. Okay, and that will be our final answer. Okay, now, last but not least, our tangents. Whew, so we're going to have derivatives, integrals. I should not have drawn that line all the way down the page because I need the rest of this page. The sound is hilarious. Okay. Whatever. I miss enormous sections where I didn't even like hit the line at all. Perfect. Okay, so we're doing tangent. I feel like these notes are getting sloppier as I go. Y is tan x dy dx is, you can write it as 1 over cosine squared x, or you can write it as secant squared x. Either one is fine. Integrals, the integral of 1 over cosine squared x with respect to x, is tan x plus c. We could also rewrite this as secant squared x dx equals tan x plus c. Hopefully you guys have heard of secant before. Secant is just 1 over cosine. Okay, it's just like a nicer way to write that, because who wants to write 1 over cosine a million times? It's much easier to write secant. So it's just that. I'm doing my examples at the bottom. Okay, so first example, I'm going to integrate 10e, I'm combining things, to the 2x cosine of e to the 2x dx. I promise you, I'll get to some more tangent stuff in a minute. Okay, so with this, we're going to have to do some u substitution. Obviously, my u is going to be e to the 2x, okay? Because e to the 2x is inside of something, okay? It also happens to be there. So that is kind of a cue. Du is going to be 2 e to the 2x dx. Can't write anything. Now, if we look at what we need to sub, we have a 10 e to the 2x dx. Okay, that's all the stuff that we can't replace with just u. Okay, actually, I guess we could replace that with u. It would just be a little annoying. 10 is here, 2 is there. We need to multiply both sides by 5. The reason why we don't just put u here is because this is the chain rule. We're going to end up with like a u on the outside, so we know that this had to be part of this du. If we just put a u there, then you'd end up with like multiple terms or multiple factors of this e to the 2x, more than you wanted. So that's why we end up doing this. Okay, now this thing is exactly like my pink stuff in my equation, so I can replace everything. So this is going to be 5 cosine of u du. Now look at that. That is just so much nicer. We can easily integrate this. Okay, sub our u back in. E to the 2x. Add on a c and we're done. Example 1, check. All right, let's do example 2. I'm going to do y equals the natural log of sine of x. I am layering things up, okay? Our goal here is to find y prime, okay? And so I'm going to find, so y prime is going to be 1 over the inside of the stuff that's inside of the log. So 1 over the sine of x. Then I have to multiply by the derivative of that stuff. So I have to multiply by cosine of x, because that's the derivative of sine of x. So this gives me cosine x over sine x, which is fun. That's it for that, I guess. Yeah. If you did this, so this guy is not cosine, cotangent. So if maybe we did this with cosine inside instead, we would get 1 over cosine x times negative sine x, which gives me negative tangent x. So that's kind of cool. All right, so now that I'm done nerding out about that, I'm going to nerd out about something else. So let's flip over the paper, because I think we're going to have, unless you have a lot of room left or you write super tiny like Isabel or Megan, you guys write tiny. I guess I see your handwriting because I still see it on the computer, but I'm seeing papers, sort of. I got a little overwhelmed with grading. Okay, so I'm going to show you guys why we kind of did it on exploration, but I'm going to actually show you why tangent, the derivative of tangent is secant squared. Okay, so We know that tangent is just sine over cosine. Hopefully you've made this cool connection. Like tangent line is the slope of a line. Slope is rise over run. Sine always does the vertical component or rise. Cosine always does the horizontal component or run. This is really just slope. So if you're like, is tangent related to our function and like tangent lines? You are right, and this is why. Anyways, we're going to do the quotient rule. I did this on the exploration. You could have done it a different way. Quotient rule. U sine x. I'm going to write all this out because it doesn't get complicated for this, but it could get complicated. U prime cosine x. V cosine x. V prime negative sine x. This is super cool. I love this. Also, if you do any sort of math in college, you'll probably have to do this proof at some point with something at some point. So our u prime, our y prime is going to be let's do it our little rhyme way. Some of you hate this, I think, but whatever. So our ho was v, so it's ho d high. So it's v u prime minus high d ho, so u v prime, all over our ho squared, which was v squared. Okay, so we can rewrite this, subbing in these little guys for this. So we should have, let's see, cosine x times cosine x minus sine x times negative sine x all over cosine squared x. Now, this is super fun. Double negative makes a positive. Ugh, why would I do this? Cosine x times cosine x is cosine squared x, right? We're just squaring it. Double negative makes a positive. There's two of them, so we'll just square it. And then all over cosine squared x. Now, this is the Pythagorean identity. Sine squared plus cosine squared is always 1. So we get 1 over cosine squared x. And that is the same thing as secant squared x. Okay, so the Pythagorean identity is sine squared x plus cosine squared x equals 1. Okay, so I just used that right here, okay, to replace it with 1. Yeah, all right. So now we are finally done with notes for today. I hope that that was beneficial for you guys and it wasn't too much. I miss you guys a lot and I hope you guys have a great day. I'll see y'all later.